All right, dude, we are live. What's up, guys? This is Demkeys, and today we are going to continue um, learning on Kaggle. We are currently on the Intro to Machine Learning course. Yesterday, we were doing was it Intro to Python or just Python? No, there was an Intro to Programming, and then there was a Python course. So I didn't finish the course on stream. I didn't finish the Python course on stream, but after ending the stream, I spent some time going through the remaining chapters and their exercises, and then I finished the course. So I'm done with, well, I mean, I finished the intro to programming thing last year, which at this point I don't even remember what it had because I was just completing it for the sake of completing it. I don't even remember what it had, but yeah, the Python one was interesting because though I have a decade's worth of experience in Python, these exercises they encourage problem solving, and in that problem solving, you kind of you kind of get to practice concepts that you might not usually practice. So that was interesting to go through. And something that I really liked about these exercises is that they give you hints and they also give you solutions. So you're not going to be stuck with one exercise for hours and hours. You can take hours and hours if you want, but you don't have to be stuck with it. You can very easily look at the solution because for every exercise they give you the solution. But yeah, I'm done with the Python course on Kaggle, and now we are moving on to the Intro to Machine Learning course. And this course as well, I've finished. As you can see, hold on, let me go to the browser. Yeah, as you can see here, I've already finished 50% of this course. This is from like a while back. This is actually probably a year ago at this point. I think it was a year ago. Yeah, I think so. I don't remember. This was like because like that intro to programming course, I went through it as soon as I joined Kaggle, which was sometime last year. And yeah, I believe I went into the intro to machine learning course last year as well. And then I kind of just left it because I got busy doing other like deep learning stuff, learning how to build build neural networks and stuff like that. So now we are getting back to this, and I'm excited because yesterday I spent some time looking at all of the various courses that are available, and dude, okay, they introduce. Oh, give me a second. Yeah, they they introduce you to various concepts of data science. They don't stick to just deep learning. Deep learning is just like one or two sections of it, or maybe three sections, where they'll introduce you to feed forward neural network, a convolutional neural network. I think maybe they go into recurrent neural networks. I'm not sure. I can't say anything about that, but they do introduce you to the concept of neural networks, but they don't really stray too far away from data science itself. They stick to the data science side. Not all of data science involves deep learning. Not all of data science involves neural networks. And you get a pretty decent example of that by going through these courses because these courses stick to various libraries like scikit-learn, NumPy, Pandas, Seaborn. That's something I was actually pleasantly surprised by, and at this point I'm wondering if that is how I found out about this library. Because if you look at the data visualization, hold on, let me see if I can bring it up. So there's the data visualization course, right? And I noticed the name Seaborn in the data visualization course. Give me a second. I don't know where the thing opened up. Here. Okay. So let that open up and then I can show it to you. But yeah, here, instead of talking about Matplotlib, which is what I had started learning data visualization with, they jumped into Seaborn. The interesting thing about Seaborn is that Seaborn was built on top of Matplotlib initially. Initially, a lot of its functionality was meant to be essentially higher level functions for Matplotlib. So you don't have to go down to the lower level and focus too much on customizability of the graph. You don't have to focus too much on the inner workings of the graph. You can just use these higher level functions to accomplish quite a lot. And that was amazing. Over time, I believe they did develop their own. They did sort of I don't know what term to use here, branch out. They sort of developed their own separate thing, which I don't know if that still uses Matplotlib or if it's their own rendering logic, or maybe they're not using um, maybe they're not using Matplotlib's functions, but they're using Matplotlib's like rendering capability, or maybe they just came up with their own rendering capability, but it's like a different kind of API. It's a different way of creating graphs. And yeah, so I was yesterday I opened up this data visualization course, and then I was wondering if this was how I was introduced to Seaborn, because I don't remember at this point how exactly I found out about Seaborn, how I found out that there is a library called Seaborn. Just a second. Yeah, I don't remember how I found out that there was a library called Seaborn. I'm willing to bet that it was probably through Kaggle itself. I never went forward with this course. I'm going to move forward with it though at some point later on, because after Intro to Machine Learning, we have the Pandas course, which is yet another course that I never really bothered going deeper into, because at that point I already knew uh, quite a bit about pandas. I mean, I'm not an expert by any means. There's a lot, dude. Pandas has a lot of stuff. So I mean, you can't just learn all of it. Generally, you kind of want to learn the stuff that you need. So stuff that is useful for you. So you learn sort of a base set of skills so that you can do very basic pandas stuff. And then if there's something more advanced, like filtering based on specific criteria, or if you want to use more than one search index, or if you want to turn, I don't know, dates into search indexes, or yeah, yeah. So like in my case, I learned the basics of pandas, and then the advanced stuff, I only learned what was necessary for stuff that I needed to do. There were certain projects that I was actually using pandas for, like real world projects that I was using pandas for. And so for those specific purposes, I learned what I needed to learn. And of course, I learned the base skill set as well. Now, I believe here, once we get into the pandas course, they're going to be teaching us the base skill set, but they'll probably also be going into various pandas related skills that are data science related, or rather I should say various pandas skills that are data science related. They're going to be going into those as well. So I'm excited to go into that. Give me a second here. I'm just creating this environment. Let me just make sure that we have proper, yeah, we have proper display. Let me open up my stream. on my phone so that okay, all right. So here's the plan. Okay. Actually, wait. Let me set this thing up. So we'll create the environment, and then we will activate the environment with env bin activate. And then we want to install NumPy, Pandas, Matplotlib. Hold on, Matplotlib, and then Seaborn, and then scikit-learn. I don't I don't remember what the thing is written as, because I think at one point maybe it was named sklearn, or maybe it's always been scikit-learn, but like the namespace that you access is I don't remember. Okay, if there's an error, it'll give an error. Okay, so then we have after scikit-learn Data. Just for the heck of it, I'll install Data in case I need to look at certain data sets. And yeah, I mean, this is going to be, from what I remember, when we had gone through this course previously, we were mainly using scikit-learn. We weren't using something like PyTorch. I don't think we were using data sets from Kaggle either, but I could be wrong about that part. Maybe we were using data sets from Kaggle. However, this is an intro course, right? So I'm guessing they probably used the data sets that are provided by scikit-learn, because scikit-learn provides data sets out of the box, but also it has an API that lets you download certain data sets. So in terms of getting started with data science stuff, you do have a couple of data sets available at your disposal. Okay, let's start this and then wait, did I do it right? So data science, then we move into data science, then we create the environment, then we activate the environment, and then yeah, we are good. Okay, so what was I saying? I don't remember what I was saying. Oh yeah, I was talking about the workflow. The workflow that I'm going to be using this time is I'm going to read I'm going to read the course material, the tutorial stuff. Definitely. Wait, why am I here? We need to be in this, how models work. And I believe I also opened this up. Yeah, I opened this up and went to the end already. Um, I hope this thing comes up later on. For now, I'm going to click not now so we can just read through the thing. Oh, good. Okay, this is done. So let me just open up NeoVim. And in here, we can create a new file called py01.py and save that. Okay, we are good. So let's just confirm that we have scikit-learn. We do. Yes, we have scikit-learn. So the reason I want to use this setup this time is because something that I remember being an issue back then was that as great as Kaggle notebooks are, sometimes IntelliSense, actually quite often, to be honest, quite often IntelliSense does not work on Kaggle notebooks. I don't know if that's something to do with my machine or if that's something to do with their platform. For a while, I did manage to get IntelliSense to work, but then after a while, it just stopped working. It just wouldn't come back on at all. So this time, what I want to do is when I see something being practiced, or when I see something being taught, and they're like, okay, you can practice this by typing so and so code. Instead of typing it into the Kaggle notebook, I'm going to type it out in my NeoVim instance so that I'm able to, so that, hold on, words, so that I'm able to practice it in NeoVim, and I'm able to benefit from um, I'm able to benefit from a lot more real estate in terms of coding. Like I have more space to code with, to code in, and I also have an environment where IntelliSense is definitely working. And then, I mean, when it comes to the exercises, I'm definitely going to have to write out the code in the Kaggle notebook, but at least for the sake of experimentation, I will be able to use IntelliSense on my end and then write out the entire code on my end, and then I can kind of retype that code into the code cell. It's kind of a it's a weird workflow, but it works. It works for me, I should say. It works for me. Um, Give me a second. Okay, so this first lesson does not have. Actually, I just remembered something. Give me a second here. Let me. Oh, I need to work on this as well. Yeah, I need to work on this as well because I've just not been touching this at all. Actually, at this point, I think I'm done with this entire thing completely. Like Git UI, at one point in time, I was exploring it, and then I kind of learned all of the stuff that I needed to learn. I relearned the basics, but this time using Git UI. And then I also got to the point where I wanted to get, which was learning about branching and remotes. I'm now, I mean, I've set up local branching and I've also set up branching, I believe, I believe using, I'm trying to remember if I had done that using local or was it actually remote? I don't remember if I managed to set up the thing across, if I managed to set up the thing to be across LAN. I think I did. I think I did set up something to be across the local network, and it did work as well. One of the things that I do need to set up now is setting up remotes for GitHub. So having a clone here, but then setting up a remote there, and that's going to be the sort of central repo. And that's where, the data is mainly going to be. And then I'll pull from there and also push changes to there. I haven't tested that part out yet. I need to set that up because there are public repos that I've been meaning to set up, but I haven't set them up yet because I wanted to learn this, Git and Git UI workflow through the terminal. So now that I've set that up, I can actually go ahead with that. What all did I have under this? Okay, types, possibilities. Man, I remember all of these brainstorming ideas and stuff that I had. Okay, we'll get into this later on. For now, we need to get into VS Code projects, Python, what was it, data science? Yeah. And then let's do source env bin activate. And this is going to be where we will access our images from. So what I need to do is create a directory for images. And let's just make sure the directory shows up here as well. It does. So each time we have any images to show, we'll put them in this directory, and then real quick I can just come here and use kitten icat, which is this, and I can drop the image name, and it'll load up here. So this will be great in terms of like visualization, though I don't think we are there yet. I don't remember if they actually do. So okay, this was the interesting thing. I didn't do this part on stream, but I did go through this off stream. In one of the chapters, towards the end in the Python course, they did actually introduce us to Matplotlib, but not exactly introduce us to Matplotlib. It was more like, okay, this is the scenario, and in this scenario, this person is using so and so library to get so and so job done, and you have this very specific problem that you need to solve. And within this type, there are these three specific functions that you need to look at. And but like this is out of the maybe 20, 30 functions that the type already has implemented. They gave us the names of those three specific functions so that we could look up the help documentation for them and understand how those functions work. And in my case, because I had this NeoVim instance open, so I was just able to, practice it with that. Dude, I cannot overstate, I cannot overstate how important intelligence is when you are doing any sort of coding, and especially like when you're doing uh, when you're learning coding, when you're learning how to use when you're either learning coding or you're learning how to use a new library and you have to explore a bunch of things. Intelligence definitely helps because, dude, things would be so much faster if you knew exactly what the name of the function is, and if you knew all the specific parameters that you're supposed to be giving it. Like imagine having to remember all of the parameters, and imagine when a function has like, I don't know, 5, 10 different overloads. So there's different sets of arguments that you can give it. Then it's just, dude, it's not feasible to, it's not even intuitive to remember all of that. Instead, if you have intelligence pop up something for you, like let's say, for example, I do a equals 1, 2, 3 x, okay, and then I wanna find out if this string is all digits. So then I'll do a dot is digit. Now imagine if I had to remember this function name, and instead of is digit, I thought it might be is underscore digit. And then I'll type that, and then I'll get an error, and then I have to go and search if this is exactly what the function name is. It's a huge waste of time. It's a massive fucking waste of time. Like you do not want to be doing that. So you definitely want an environment have uh, where you have intelligence, where you're able to benefit from intelligence, because trust me, it is going to benefit you. There's nothing lazy. There's nothing lazy about using intelligence, and I'm bringing up the lazy point because you throughout your coding journey, you will come across at least one elitist programmer who's going to tell you that IntelliSense and all of these refactoring tools and all of these things, these are for people who are not real programmers. Those kinds of clowns exist. Unfortunately, you will come across those kinds of people. So if you are new to any programming language, I don't know why I went on this tangent, but like if you are new to any programming language, um, or any new library or whatever, there is no shame in using IntelliSense, and I explicitly look for IntelliSense in any environment that I'm going to be coding in. If NeoVim did not have IntelliSense working, believe me, I would ditch it so quick. I would not bother coming back to NeoVim if it did not have IntelliSense, because I need that for all the languages that I code in. I'm not going to sit and remember specific names and um, specific argument orders and specific like overloads and all of that. No, I'm not going to do that, dude. It is incredibly it's incredibly inconvenient, but also very unintuitive. Okay, enough of my tangent. Give me a second here. I love how quick it is to do this from the phone, dude. I should see if there's a way to automate that as well. Speaking of which, yeah, dude, I need to get back to Rust as well so that I can, dude, I wanna explore the Twitch library on that's implemented with Rust, that's implemented in Rust. I wanna explore that because there are certain Twitch related things that I want to do using Rust. But yeah, okay. Anyways, so this is where we are currently at. Now, let's start reading this. This text is small, so I'm going to open this up on a different machine. I actually do have it open on a different machine already. So give me a second while I open that up. Where is it? Okay, just a second. Okay, I thought I had opened it up, but I guess I did not, so I'm not going to waste time now. I'm going to directly open up Kaggle Learn, just so I can read the thing. Because I have the thing opened up on another machine as well. Well, I'm opening it up now on another machine, where I have the page zoomed in a little bit. I don't want to zoom in on this page here on this machine where I'm streaming from, because then it causes problems with other stuff. So it's simpler to zoom in here. Okay. Introduction. We'll start with an overview of how machine learning models work and how they are used. This may feel basic if you've done statistical modeling or machine learning before. Don't worry, we will progress to building powerful models soon. This course will have you build models as you go through following scenario. Your cousin has made millions of dollars speculating on real estate. He's offered to become business partners with you because of your interest in data science. He'll supply the money and you'll supply models that predict how much various houses are worth. Okay. You ask your cousin how he's. Wait, give me a second. Oh, that went off. I need to put that on charge. So just a second. Okay. You ask your cousin how he's predicted real estate values in the past, and he says it's just intuition. But more questioning reveals that he's identified price patterns from houses he has seen in the past, and he uses those patterns to make predictions for new houses he is considering. All right, let's read further. If you will let me scroll. Okay. Where was I? Yeah. Okay. So, machine learning works the same way. We'll start with a model called the decision tree. There are fancier models that give more accurate predictions, but decision trees are easy to understand, and they're the basic building block for some of the best models in data science. For simplicity, we'll start with the simplest possible decision tree, which is this. Okay, so what is this showing us? Does the have does the have does the house have more than two bedrooms? If not, then the predicted price is 178,000. If it does, then the predicted price is 188,000. Okay, right. So what does this do? It divides houses into only two categories. The predicted price for any house under consideration, is the historical average price of houses in the same category. We use data to decide how to break the houses into two groups, and then again to determine the predicted price in each group. Wait, run that back. We use data to decide how to break the houses into two groups, and then again to determine the predicted price in each group. Okay. The step for capturing patterns from data is called fitting or training the model. The step of capturing patterns from data is called fitting or training the model. The data used to fit the model is called training data. Okay, I remember this being a sort of point of confusion for me in the past. Each time when I was learning anything data science or ML related, it was this thing like, okay, what exactly does it mean to fit data to a model? What exactly is sorry, zoned out for a second. Yeah, these terms like fitting a model and overfitting and underfitting, um, these things kind of they would confuse me initially. So when I first got into machine learning and I started learning this through Kaggle, it kind of started to make sense. But then I don't think I've gotten to that point where I've fully understood the meaning of these kinds of terms. Like when we say that we are fitting certain um yeah, I don't even know how to use it in a sentence. Like listen to how I'm stumbling. Uh Hold on. This step of capturing patterns from data is called fitting or training the model. The data used to fit the model. You see that wording, the data used to fit the model is called the training data. Fitting the model. These things I need to be able to like visualize this to understand the vocabulary, to be able to like understand what exactly is going on when something like this is said. Though I feel like once I start doing this practically, then the words might make sense. That just occurred to me. Once I start doing this practically, then it's going to make more sense that, oh, yeah, these words, they mean this. So my mind might form its own pattern, its own way of understanding that, hey, this means this. All right. The details of how the model is fit, example, how to split up the data, is complex enough that we will save it for later. After the model has been fit, you can apply it to new data to predict prices of additional homes. So something that I remember about fitting was when we were learning about linear regression. The idea there was that given given a set of data points, we try to find the line of best fit. So this is a line that best fits this entire set of data points. So like if you were trying to draw a line through a given data set that somehow captures all of them at like um I'm not sure if I should say equal distances, not exactly equal distances, but like it's a line that best fits within this group of points, this group of data points. That was the whole point with linear regression, where you are able to find the line of best fit. And once you've found the line of best fit, you can then use that line to predict values on new data. So your previous data points would be your training data. So in the case of something like, let's say, housing, you would say X number of rooms is that price, and then X number of rooms is that price, X number of rooms is that price. And just like this, you have like 20, 30, 100, 1,000 such pairs of data. So you have on two separate axes, right? And then you plot the thing, and you can see your group of data points. And then you try to find a line of best fit. Once you have that line of best fit, you can use that line of best fit to predict values for new values, if that makes sense. You can use that to predict new values based on new inputs. Okay, enough trying to explain this thing. Actually, this thing said the exact same thing. After the model has been fit, you can apply it to new data to predict prices of additional homes. Which of the following two decision trees is more likely to result from fitting the real estate training data? Wait, give me a second. Let me hydrate. Okay. Wait, what does this say? Dude, you know what? I think I think there's a way. No, I'm not going to be able to see images if I do that. I was trying to think of a way to, because like there's a way to write your Python code, or well, there's a way to format the code in your Python script such that you can then pass it into a tool that will read certain like format specifiers, and based on that it'll determine that okay, this is supposed to go into a markdown cell, that should go into a code cell, and so on. So I was wondering if there's a way to do the reverse of that, and then I could just download these notebooks and then open them up in NeoVim. So like after, parsing it into a Python script. And while I think that would be possible, I'm pretty sure there would be a way to do that because you can actually read the data in these notebooks. So I'm pretty sure there's ways to extract the data from them and like parse them into some other format. I don't think it's going to show. I don't think it's going to display the images very well, and these kinds of images are a good example of that. So I feel like that would end up being a waste of time. The problem is, dude, with this UI, when I zoom in, I'm not able to get as much as I need from it. If that makes sense. Because like as I zoom in, you look at this section where it says how models work, and this entire section is just like a waste of space for me. I could be using this space as well, but like I can't because there's no option to collapse that. And I have a similar issue on the other machine where I'm reading this stuff because I'm actually zoomed in there for the sake of being able to read it. And okay, anyways, I'm gonna stop complaining. So improving the decision tree. Which of the following two decision trees is more likely to return? Which of the following two decision trees is more likely to result from fitting the real estate training data? Okay. Let's take a look at the decision tree. So, first decision tree, does the house have more than two bedrooms? If no, then it's 178,000. If yes, then it's 188,000. Okay. The second decision tree says, does a house have more than 2 bedrooms? I thought it's going to be something different, but this is just flipped, isn't it? Yeah, so in this case, if it doesn't have more than 2 bedrooms, then it's more expensive. And if it does have more than 2 bedrooms, then it's cheaper. Okay, moving on. The decision tree on the left, decision tree 1, probably makes more sense because it captures a reality that houses with more bedrooms tend to sell at higher prices than houses with fewer bedrooms. Okay, that makes sense. The biggest shortcoming of this model is that it doesn't capture most factors affecting home price, like number of bathrooms, lot size, location, etc. Okay, you can capture more factors using a tree that has more splits. These are called deeper trees. A decision tree that also considers the total size of each house's lot might look like this. Okay, let's take a look. Okay, does the house have more than 2 bedrooms? If not, then the lot size is the lot size larger than 8,500 square feet? Okay. And if it does have more than 2 bedrooms, then is the lot size larger than 11,500 square feet? Is that 11,000? Yeah. Okay. All right. Okay. You predict the same. You predict the price of any house by tracing through the decision tree, always picking the path corresponding to the house's characteristics. All right. The predicted price for the house is at the bottom of the tree. Dude, I remember now that back when I was going through these chapters, and as I would keep going through various machine learning courses and various machine learning tutorials, I would kind of get hung up on trying to understand each of those methods in deeper detail. And then eventually I would just get distracted with something else and just not come back to that topic. I remember doing that with even with decision trees. Like I remember trying to understand how decision trees work because I wanted to get an understanding of exactly what is going on. You know, I wanted to understand how to visualize it, how these trees work, how these trees are constructed in the first place, what's going on there, you know? Because with linear regression, at least with two-dimensional data, you can visualize it. With three-dimensional data, also you can visualize it, but then past that point, it becomes a little complicated to visualize the data as you have more and more parameters in there, or I guess they're called features. As you have more and more features in the model, then um, the it becomes a little harder to visualize it, but you're still able to get the values. You're still able to fit. You're still able to get the line of best fit, and based on the line of best fit, you're still able to do your prediction, even if you can't necessarily visualize higher dimensional data. You can still use the value, and I guess that's also the case with this. I'm gonna have to see like to what extent this ends up being multidimensional data. But yeah, yeah. So you predict the price of any house by tracing through the decision tree, always picking the path corresponding to the house's characteristics. The predicted price for the house is at the bottom of the tree. The point at the bottom where we make a prediction is called a leaf. The point at the bottom where we make a prediction is called a leaf. Okay, that is down here. Okay, all right. The splits and values at the leaves, hold on. Yeah, the splits and values at the leaves will be determined by the data. So it's time for you to What? The splits and values at the leaves will be determined by the data, so it's time for you to check out the data you'll be working with. Okay, so now we go into this. Examine your data. I hope this is the right, yeah, okay. Basic data exploration. So this moves on to the next tutorial, which is basic data exploration. And apparently I'm done with reading this as well. Actually, yeah, I'm done with reading this and doing the exercise as well. That exercise and the exercise on on the next chapter as well, I'm done with both of them. Because I remember that in one of these, we trained a model and then made a prediction. And then I stopped at the point where it was, there was a word. I can't remember what the word was, but like it was trying to figure out the quality of the prediction, the quality of the model, like how well the model performs. There was a word for that. I forgot what the word is, but that's also coming up next. That's kind of where I'd stopped. I didn't really go further from that point. I didn't even learn like that point. Like how do we evaluate? I think evaluate model evaluation. How well the model is performing. I don't think we ever went further with that. Okay, now wait for this thing to load, and once it is loaded, I can start reading. Give me a second here. This thing is not letting me scroll for some reason. Am I not hitting the right keys? Okay, all right. That's weird. Okay, that's where I need to. Okay, great. I need to remember that here as well. I need to click here in order to be able to scroll. Right. Using pandas to get familiar with your data. The first step in any machine learning project is familiarize yourself. What? The first step in any, okay, I guess I was expecting it to say familiarizing, but I guess I was wrong. The first step in any machine learning project is familiarize yourself with the data. You'll use the Pandas library for this. Pandas is the primary tool data scientists use for exploring and manipulating data. Most people abbreviate Pandas in their code as PD. We do this with so and so command. Yep. Okay. You know what's interesting? I'm glad that I took the time. I've mentioned this before. Before getting into machine learning, I took the time to learn NumPys. NumPys. What? NumPy. I took the time to learn NumPy, Pandas, and Matplotlib. I would definitely recommend people learn all three of these. Not like don't go deep into it at all. Learn the basics. You need to learn the basics of these. And the amazing thing is, all three of these platforms, you go to all three of their websites, they provide you with excellent material to just get started. Like they will introduce you to the basics of these libraries and get you up and running, and then further from that point you can decide if you want to continue looking into more advanced stuff in each of these libraries, or if you want to just jump into doing data science stuff or machine learning or whatever. Because dude, as you continue doing data science and machine learning and deep learning and all sorts of AI stuff, you are going to be using these libraries. You're going to be using NumPy and Pandas quite a bit. Pandas probably depends like what kind of work you are trying to do, because Pandas is more about like creating data frames, which are essentially like tables, but like very advanced tables. It's not as simple as, a couple of columns, couple of rows. There's a lot more advanced stuff that you can do in there. You can have stuff like, if I remember, there's stuff like tables within tables. There's different ways of indexing. There's also a concept of multi-indexing. I don't remember. That's actually something I never got a chance to explore more in Pandas. But now that I have a proper working environment, dude, so much has changed for me. So much has changed for me. Moving away from VS Code and then going to Kaggle, and then from Kaggle, I didn't really move away from Kaggle. I just moved away from VS Code and then moved over to NeoVim. And then I tried to move my workflow from Kaggle over to NeoVim, because of which things are going to be so much faster, especially in terms of experimentation and learning and exploratory data analysis and all sorts of AI and deep learning. So it's gonna be so much more smooth. It's gonna be so much more fluid, let's say, because mainly because of IntelliSense. Okay, anyways, where was I? You'll use the Pandas library for this. Pandas is the primary tool for data scientists. Primary what Pandas is the primary tool data scientists use for exploration, for exploring and manipulating data. Most people abbreviate. Actually, yeah, okay. I mentioned earlier that Pandas is it's mainly for like data frames and stuff. This is part of it. Like, it gives you extremely optimized methods for performing operations, various types of operations on the data. And you can have those operations be, I don't want to say vectorized, but they would be performed in a much more optimized way than just iterating over an entire collection and, you know, doing operations on each one of those items. No, they've found ways to do it in much, much quicker, much more optimized, much more efficient ways. Okay, so the most important part of the Pandas library is the data frame. A data frame holds the type of data you might think of as a table. This is similar to a sheet in Excel or a table in a SQL database. Pandas has powerful methods for most things you'll want to do with this type of data. As an example, we'll look at data about home prices in Melbourne. Hold on. What does this link to? This links to, now it doesn't say that it's a, let me open this up here, because opening it up on the streaming machine is going to be super slow. Okay, so this is a data set. So we're gonna need the data set. Right. So to do this, how do I go about doing this? I need to be able to send this over to the other machine. So I can download it here. What happens if I download this? What is this going to give me? Is it one file? We have data card, we have code, submissions. Oh yeah, it's one file. It's a CSV file. Dude, I wonder if I can just copy the entire raw CSV data. Oh yeah, it's one CSV file, right? Why don't I just copy the entire CSV data and then paste it into like a data set here? Why did this download as a zip? Why was that necessary? If you can just give me the raw CSV data, that would be amazing. I can just copy that and we're good to go. Is there a way for me to look at the raw CSV data? because I don't want to unzip that. I mean, okay, I can unzip it. It's fine. Let's go over here. I'm gonna have to do something off stream real quick. I accidentally did something here that I wasn't supposed to do. So let me just fix that. Yeah, there. I should also detach from here. That's much better. Right. In here, I need to open up Yahtzee and go to the downloads folder and unzip the thing. So just give me a second here while I do that. And then in the meantime, I believe, yeah, I could create the thing. What's it called? It is called melbdata.csv. I'm gonna have to find a more streamlined way of doing. I could just use the Kaggle CLI to do that. Like in the future, I could just use a Kaggle CLI. That would work out a lot. Oh, that's something that I forgot to install here. Actually, to be fair, I didn't know that I would need the Kaggle CLI. So yeah, I didn't forget to install it. I could install it. Um, okay, did Yahtzee open up? Okay, cool. Now let's go into the downloads folder where the thing just downloaded. Okay, do the sorting thing and then open up this zip folder. Okay, I should definitely be careful here because this thing zipped into, yep, you know what? I need to be careful here because this thing just zipped into, like it extracted directly into the downloads folder. Fortunately, there was only one file, so it didn't really cause too much harm, but that could have been bad. Okay, so let's open this up. Give it a second while this thing opens up because I think there's quite a bit of data in there. Big file detected. Some NeoVim features have been disabled. Okay, that's fine. Right, so we will do the visual mode thing and actually, no, wait. So I've started up visual. No, hold on. I could just do a yank operation. So yank all the way to the end. That is a lot of data. I don't know if that's even going to paste properly. Let's hope so. I don't know. What's okay? I did the paste. Oh my God. Well, that's all. That's all the data. Cool. Is that all the data? Hold on. Let me confirm. Yeah, that's all the data. So this is our CSV file. I need to find a better way to do this. This is definitely not a good way to go about it. Let's close this buffer. And now we have our thing here. Okay, cool. So as an example, we'll look at, wait, I need to go to the other more zoomed in thing. As an example, we'll look at data about home prices in Melbourne, Australia. In in the hands-on exercise, you will apply the same processes to a new data set which has home prices in Iowa. Um, the example Melbourne data, the example Melbourne data is at the file path so and so. Okay. We load and explore the data with the following commands. Okay, we can, oh, accidentally dropped something here. Speaking of dropping, okay, I have no idea how to connect that. Why did I say speaking of dropping stuff? Uh, Give me a second. I'm just loading something up. But yeah, this is showing us how to, where did I save the, where did I save the data set? The data set is saved in, I should have put it in like a data folder. Yeah, I should have put it in a data folder. So let's open up Yahtzee and let's create a data folder here. That is a file. Let's create a data folder here and move this into this. Okay, cool, great. So now we have a data set folder, and in that we have the Melbourne thing. Cool. So first we have to do import pandas as PD, and then we have Melbourne file path equals. Does this not take like a relative? But oh wait, this is for the, yeah, no, hold on. Here I would just need to do data, right? Yeah, okay, dot. Dot is for the current directory, and then data, and then Melbourne data CSV. Okay, this save the file path to a variable for easier access, then read the data and store data in data frame titled Melbourne data. All right, let's do that. So melb data equals pd.read CSV. See, this is one of the things that I would always have like that issue with, where it's like, okay, what is the name of the function? What are the specific parameters and stuff like that? And now I can just use this. Okay, melb file path. So that reads the CSV. There's no extra parameters that you have to give it. And then we have melb, okay, melb data. What did I just type? Melb data.describe. This is going to return something, right? This returns a data frame. Let's print out the data frame. I should probably also use the pretty print, um, option. There was a specific library. I think it's part of the standard Python library. If not, then I might need to install that set. There was actually a separate library as well. I don't remember the name of the. I'm curious. Hold on. There was a Python pretty print library. The name, for some reason, I think it was something. For some reason, I'm remembering it as something close to like kitty or cat or something like that. Okay, Python pretty print library. So there's pprint, which I believe is part of. It's part of the standard library, and then there was not rich. It wasn't called rich. It was not called rich. There was. It wasn't pprint either. Well, I mean, pprint was the one that I was talking about, which was part of the standard library. But there was another one that I'd seen, which Was it rich? I don't think it was rich. It wasn't rich. I don't think it was rich. But for some reason the thing is not popping up here. Let me see if someone suggested it on like Stack Overflow or Stack Exchange or something. Somebody must have mentioned the name. That's how I'd found it. Okay, so there's pprint, which yeah, we know about that one. Um, no, dude, there was something with the name. Okay, pretty print a list and pretty print output in Python. Okay, I'm looking for that name. For some reason, I'm like really focused on that name, even though I'm not going to be installing that, but like I'm focused on that name. Wait, let me see if I can ask Gemini in one of my other conversations with it. Just a second here. Yeah, I think I've opened way too many Gemini instances here. Dude, ever since I started using Gemini CLI, I've been doing a lot of it like locally, or rather using the terminal than using the browser. And honestly, I'm loving it. Like it is great. Though it does take a couple of seconds to start up when it's a new instance. But if I'm clearing out an older instance, like reusing an instance, then it's pretty quick. This was an open source library, and this was actually a very apparently a famous library as well. I cannot remember what it was, what the name was, and at this point, I can't remember if it was for Python. Was it for Python or for Rust? Oh God, dude, am I remembering wrong here? Okay, a while back, I had seen a library, a Python library on GitHub that was meant to handle pretty printing in Python. For some reason, I remember the name having kitty or cat or something like that in its name, or maybe something to do with cats. I just can't seem to remember the name of the library. I know that there's pprint, but that's not what I'm talking about. Yeah, okay. Something else that I really liked about Gemini CLI is that it has like this Google search option. So you can actually use it to do a bunch of research. Like there was an internet personality who I watched a lot back in the day, who had become very famous on social media through their like various like homemade videos with their family and stuff. And I was trying to kind of catch up with like how they've been and what they've been up to and all. And apparently that information was also on there, like on the internet, and through the Google search, I was able to catch up. Like, hey, this is what they've been up to, and I actually found them on TikTok. Like now, years later, I found them on TikTok, which is what made me wonder, hey, what's this person been up to? I've not seen this person in like ages. What have they been up to? And then Gemini was able to give me the rundown. Okay. Um, Unfortunately, as much as I just hyped up the Google search, even that didn't return anything. Uh, okay, I'm wondering if I'm confusing or if I'm mixing up languages here. Could it maybe be a Rust thing? I don't think it was a Rust thing though. Okay, what about specifically JSON and dictionary pretty printing library in Python? Yeah, dude, I'm for some reason I remember something. No, I mean, yeah, okay, never mind. Uh, Dude, I can't remember what the thing, what the name of the library was. But there was a library. That's that's all I remember. There was a library that okay, let's take a look at FMT. It says it's a modern formatting library. Okay, pprint. No, this is not the one. I'm curious now. Okay, I'm gonna have to do this search after the stream. But for now, we can continue with this. Give me a second. Let me hydrate a little bit, and then we'll continue. Actually, we could use pretty print for now. Data pretty printer. The pprint module provides a capability to pretty print arbitrary Python data structures in a form which can be used um, as input to the interpreter. If the formatted structure includes objects which are not fundamental Python types, the representation may not be loadable. This may be the case if objects such as files, sockets, or classes are included, as well as many other objects which are not representable as Python literals. Okay, so there's pprint.pp. This prints the formatted representation of an object followed by a new line. This function may be used as an interactive interpreter instead of the print function for inspecting values. You can reassign print equals so and so for use within a scope. Okay, let's try that out real quick. Give me a second. So we have okay, import. What was that, dude? Okay. Um, import pprint as pp. And then, dude, suddenly I'm remembering doing this on stream and then laughing about it, mainly because of pp. Well, anyways, so let's okay, let's create a dictionary. Okay, uh, A 1 2 3, and then B 2 3 4. Okay. Um, what are we doing then? pp.pp. Okay, so we'll save this and then, yeah, let's activate the environment here as well. And then Python py01.py. Okay, so this is our, wait, uh, this is in terminal mode, so we cannot increase the, I need to keep that in mind. We can't increase the thing. Okay, so that prints out the thing. It doesn't do a great job of like formatting it. Prettyprint stuff. Okay, this is an alias with sort dictionary to true by default, which would automatically sort the dictionary keys. You might want to use pp instead, where it's false. P format. Okay, let's try this with a list instead of a dictionary, because I might be remembering the thing wrong. Yeah, it doesn't seem to be doing anything, and I'm not sure why that is. Okay, you know what? We'll look into PP later on. For now, we're gonna stick with the data science thing. I don't want to spend too much time uh, doing PP stuff. So this is our data. This is the description of the data. All right. So after we save this and run it, it gives us this information. Interpreting data description. Let's do that. Okay. The result shows 8 numbers for each column in your data set. The first number, the count, shows how many rows have non-missing values. Do I see a count? I don't see a count. Though I am noticing that yeah, it's not showing me all of the information. It's 8 rows, right? I need this to be a bigger thing. Yeah, I think I need to be able to send this data to an IPython REPL, so I can then load the data there. I mean, I could still do it here, even in this terminal, but then I would need to, for example, go into normal mode and then increase the window size And that's going to be a little, yeah. Instead, I could do it here for now, and then later on I can set up um, an IPython REPL where I can just send this data and get the result. Okay, there's our information. So it gives us the count and then the mean and the standard deviation, then minimum, 25th I think that's 25th percentile, 50th percentile, 75th percentile, and then max. And this is for each column. Okay, that's something important to remember as well. This is giving us that information for each of these columns. Oh, you know what? I wonder if I wonder if I can pass that data into Data. Yep. Okay. So this gives us some data that we can, this gives us like an interface that we can look at. I forgot how to do Data stuff, dude. Yeah, I forgot how to do Data stuff. I need to kind of relearn the thing because I haven't touched Data in a while. Because like I'm seeing these three dots in between, and that tells me that there's more columns. Oh yeah, it does. It mentions at the bottom as well. There's 13 columns, so it can't fit all of them into the terminal, so it kind of like collapsed it. Wasn't there a way to launch Data from within? Yeah, there was a way to launch Data from within Python itself. So I could do that real quick. How to call Data from Python code. Wait, that's weird. I remember this being a thing where we could launch Data from within Python. There was a thing for that. There was definitely a thing for that. I cannot remember what it was, but there was definitely a thing for that. Well, okay. Anyways, let's continue with reading. So the result shows 8 numbers. The result shows 8 numbers for each column in your original data set. The first number, the count, shows how many rows have non-missing values. Wait, that's interesting. Wait, the first number, the count, shows how many rows have non-missing values. I never really thought of it in that way, that it's non-missing values. Okay, missing values arise for many reasons. For example, the size of the second bedroom wouldn't be collected when surveying a one bedroom house. We'll come back to the topic of missing data. Okay, the second value is the mean, which is the average. Under that, STD, which is standard deviation, which measures how numerically spread out the values are. Okay, we are coming back to these topics again. I remember I was at one point in time on stream actually. I was looking into these topics like mean, median, standard deviation. There was something more than that as well. I remember a bunch of these things like they kind of come together, and there were a couple of these things that there was one operation. I can't remember the name of that operation. Um, yeah, I can't remember the name of that operation, but that operation was then would be a result of the mean and the standard deviation. There was there was an operation. I can't remember what it was, but yeah, we are coming back to this stuff, which is great. To interpret the minimum 25%, 50%, 75%, and max values, imagine sorting each column from lowest to highest value. The smallest value is the minimum. If you go quarter way through the list, you'll find a number that is bigger than 25% of the values and smaller than 75% of the values. This is the 25% value, pronounced the 25th percentile. The 50th and the 75th percentiles are defined analogously, and the max is the largest number. All right, moving on to the coding exercise. Okay, are we done? I can't tell if we are done loading or not. But okay, let's read this. So, this exercise will test your ability to read a data file and understand statistics about it. In later exercises, in later exercises, you will apply techniques to filter the data, build a machine learning model, and iteratively improve your model. Okay? The course examples use data from Melbourne. To ensure you can apply these techniques on your own, you will have to apply them to a newer data set with house prices from Iowa. The exercise uses a notebook coding environment. In case you are unfamiliar with notebooks, we have a 90-second intro. Fortunately, I am well familiarized with notebooks. Okay, exercise. So we have to set up this thing. And then once this is done, we have to do the loading of the data. Hopefully the, so it mentions input here. These, what do you call them? These notebooks, usually they have an input section in which you can mention data sets. Yeah, there it is. So I don't know if this is the Iowa data set or, I mean, this contains Melbourne. This might be Iowa. I'm not sure. It just says home data for ML course. Give it a second. Our notebook is still, or well, the thing is still, okay, session started. Great. Awesome. Right. So loading data. Read the Iowa data file. Oh yeah, there it is. Home data for ML course train. For some reason, I didn't pay attention to the path. Read the Iowa data file into a Pandas data frame called home data. Call the line below with no argument to check that you've loaded the data correctly. Okay, that's done. Oh, this is like in a hurry to let me start the next tutorial because I'm already done with this exercise. I did it previously. I finished this exercise. I finished this exercise and the next exercise as well. So I think it's constantly going to be telling me to. Actually, oh, dude, I've done this. I've done this, and so it already has all of the stuff completed here. Oh shit, I can't go through this again. Can I go through it again? Like no, I can't. I would have to load like a new version just for myself. What happens if I factory reset it? Let's see what happens if I factory reset because how do I load a how do I load the same. Wait, let's see. Okay, that's fine. I mean, I don't wanna try too hard to like restart this entire thing when I've already gone through it. If it's gonna be too much of a hassle to do that, then I guess we'll not do that. But like there are different versions. Can I not just load can I not just load a different version of this notebook? Like a previous version of this notebook? Um Save version, version history, new notebook, rename, delete notebook. So what it did is it loaded. Oh, what happened here? Okay, never mind. You know what? I don't know enough about how this works to be able to like reset the thing. But apparently I've completed the entire exercise and it won't let me do the exercise again. I mean, I can go through the entire thing again just to refresh my knowledge, but yeah. Okay. Also, I just noticed the time. Yeah, give me a second here. Okay. Yeah, the entire thing is over. Like the thing hasn't even started. The thing hasn't even loaded and it's already like complete. From what I remember, there would have been it would have asked me to like complete certain things, certain lines of code or whatever. But since all the data is already here, it's saying it's already showing data here. So I'm guessing I can't redo this. That's fine. We can move on to the next tutorial, which is your first machine learning model. And I've done this as well. Oh, you know what I could have done? Though I would need to download the data set for that. Yeah, yeah. I would definitely need to download the data set for that, which isn't really an issue. It's just that I don't have that set up yet here. Um, okay, so this mentions which data sets are being used. So I would probably be able to download these data sets. I should do that. Yeah. Okay, selecting data for modeling. Give me a second here. Wait, so we are done with this. This is Intro to Machine Learning. So we are in this section. We are in chapter 3, your first machine learning model, and I've done that already. Then there's model validation. That's something I didn't look into. I need to see if there's a way that I can like restart the exercise. Someone must have, I mean, other people must have done this, right? Give me a second. Kaggle Learn Restart Exercise. Find the name of the exercise notebook you'd like to restart. To the right, you'll see a menu marked so and so. Okay, let's try that out real quick. Let's try that out with this one. This is the exercise. Yeah, because I kind of want to go through the thing again, even though most of the stuff that it's asking me for, I believe it's all pandas based, like in that first exercise, and I kind of already know my way around pandas. Um, okay, hold on. Somebody has answered the question here. They said more settings. Did they mean more settings? How to refresh an exercise to get the original version. According to the Kaggle Learn FAQ, you can refresh an exercise to get the original version. Do they still have that FAQ up? Because that might be up to date. My exercise progress is not 100%. I don't have a green check, but I think I have completed the exercise. What should I do? In most cases, this can be fixed by running every line of code in the notebook by selecting Run All. If this doesn't work, double check that you have gotten a correct result for every question in the notebook. If this doesn't work, reset the exercise. See, next question. How do you reset the exercise? To restart an exercise, go to kaggle.com/me/code and then find the name of the exercise notebook you'd like to restart. Okay, I'm doing this on a different machine. Okay, your notebooks, um, public notebooks. To manage your code, including private work, go here. Okay. Right. So it seems like I'm gonna have to reset these off stream, and I do want to reset them. I wanna do them from the beginning, just so I have a chance to like follow along and learn the tutorial properly, if that makes sense. That being said, unfortunately, I don't think I'll be able to do this on stream. I wonder if I can finish this entire thing today. Yeah, dude, I should have started earlier, but that's on me. I started late. Yeah, I wonder if I can manage to finish this entire thing today before tomorrow's stream. Because if I manage to finish this, then tomorrow we can look into pandas and then just do the entire pandas section. I have data viz open here. This is the pandas section. Dude, I love that they've to a certain extent gamified the learning process and even like the participation process and stuff on Kaggle because there's a bunch of different things. There's like a ranking system. Um, you can get like medals after a certain amount of medals. Your tier increases, which goes to like expert and then master and then grandmaster as well. I think, and like it's not like super easy to get to either of these tiers. There's quite a bit of work that you have to do, and I like the way that they've set this up. And even for the courses, dude, like um, I don't know if gamified is the right term to use, but it's the best term that I could come up with. I love the fact that they actually give you certificates for completing each of these courses. And the certificates are signed by, I believe, the people who were the instructors for that specific course, and maybe somebody else as well. I don't remember. But yeah, that's pretty awesome. This is a great way of learning, at least in my opinion. Now, give me a second here. Hold up. Did the stream freeze? Oh shit, the stream froze. Well, the stream didn't freeze. There's just a bit of. Hold on. What is this? Uh, Allen Robotics. I'm interested because they are okay. They are in follower only chat. So I guess never mind. We're gonna find somebody else. Give me a second here while I look. Okay, there is a person here doing calculus 2. There's another person who's, oh, it's not an English stream though, it's a Spanish stream. Okay, anyone else? Anyone else? Anyone else? I did load up somebody's thing. And we can go check them out. There's somebody else here. We are co-working super hard today. All right. You know what? Okay, we'll go to this person. Their name is D Donuts Art. D Donuts underscore art. And they are doing, I'm assuming, drawing on stream. I'm not sure. We will find out, I guess. So yeah, that's gonna be wait, let me drop the raid command there. Okay, so that's gonna be it for today's stream. I'm glad that we've gotten back into Kaggle, and this time I feel like I have a proper environment set up, and I'm ready to actually do Kaggle stuff. Especially because of IntelliSense. Like, dude, I need to look into a better workflow to be able to read a bunch of the data that's being shown. I'm sure there's good ways to read it, or at least I need to look into better ways to handle the terminal that's within NeoVim. So maybe I can like expand it. I'm pretty sure I can if I go into normal mode, but if I want to quickly open and close the terminal, I have to remain in terminal mode. Anyways, okay, I don't want to keep blabbering now. The raid timer is running out. So that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.